So welcome back. I'm Alan J and welcome to Lincoln Central with your 12th amazing trig tutorial in the Basic Trig series. In this tutorial we'll be visualizing what the cosine ratio is and doing some simple problems. So what is the cosine of an angle? If theta is an angle in a right angle triangle, we can describe the angle from the ratio of the sides. Remember, the sides are named opposite, adjacent and hypotenuse, like so. The cosine of an angle is simply the ratio of the adjacent side to the hypotenuse, or put in an abbreviated form, cosine theta equals adj over hyp. Here is a graph showing how cosine theta varies against the angle theta in degrees. You see the curve is one of decreasing gradient, and for very small angles on the left, the ratio tends towards 1. And looking to the right, for angles approaching 90 degrees, the ratio tends towards 0. Similar to before, with the sine ratio, there are three angles that have important cosine values. The angles are 30 degrees, 45 degrees and 60 degrees. Down the side, those numbers don't look particularly easy to remember, do they? Well, there is a way to actually work them out. Let's look at the 30 degree and 60 degree angles first. These angles reside in a special right angle triangle at sides 1, root 3 and 2. You can see by using Pythagoras how the numbers work. 1 squared plus root 3 squared equals 2 squared. In other words, 1 plus 3 equals 4. Now to the angles. Cosine 30 degrees equals root 3 over 2, which is 1.732 over 2, or 0.8660. Cosine 60 degrees equals 1 divided by 2, which gives half, or 0.5. From the last video, notice how the sine of an angle in a right angle triangle is equal to the cosine of its complement. In other words, sine 30 degrees equals cosine 60 degrees, and sine 60 degrees equals cosine 30 degrees. Let's now look at the 45 degree angle. These angles, there are two of them, reside in a special right angle triangle, this time of sides 1, root 2 and 1. You can see by using Pythagoras how the numbers work. 1 squared plus 1 squared equals root 2 squared. In other words, 1 plus 1 equals 2. And so to that 45 degree angle. Cosine 45 degrees equals 1 divided by root 2. This gives 1 over 1.4142, which gives 0.7071. Notice how this is also the same as sine 45 degrees. Sine 45 degrees equals cosine 45 degrees. So remember, these two triangles with sides 1, 2 and root 3, and the other 1, 1 and root 2, they're really useful. Now some problems. Basically, there are three types of problem. For each, I'll work through an example. In the first type, you're given the angle and the adjacent side and are required to work out the hypotenuse. So here we go. Example number 1. A right angled triangle contains a 35 degree angle with the adjacent side measuring 14.5 centimeters. Calculate the length of the hypotenuse. The first thing to do is to analyze the information given by writing it out in one line. Theta is 35 degrees, adjacent side is 14.5 centimeters, and the hypotenuse, well, let's just label that x centimeters, and remind ourselves that the answer is to 2 decimal places. I find it always a good thing to visualize the problem by making diagrams, so I've made a little right angled triangle with the side names, and a larger triangle with the numbers on it. First, write out the cosine ratio equation, putting a 1 under the cosine theta. So we have cosine theta over 1 equals adjacent over hypotenuse. Repeat this putting in the values of theta and the adjacent side. Then we get cosine 35 degrees over 1 equals 14.5 over x. Now cross multiplying, top left by bottom right equals top right by bottom left. This gives x cosine 35 degrees equals 14.5. So we now have a linear equation with no fractions. Make the hypotenuse x the subject of the equation by dividing both sides by cosine 35 degrees. The cosine 35 cancels on the left, leaving the x alone. So we have x equals 14.5 over cosine 35 degrees, which equals 14.5 divided by 0.8192, which equals 17.7001. Therefore, the hypotenuse x is equal to 17.70 centimeters to 2 decimal places. Now let's look at the second type. Here you are given the angle and the hypotenuse and required to work out the adjacent side. Example 2. A right-angled triangle contains a 41-degree angle with a hypotenuse measuring 21.2 centimeters. Calculate the length of the adjacent side. First, our diagrams and information. Theta equals 41 degrees, hypotenuse equals 21.2 centimeters. Let the adjacent side equal y centimeters, and remind ourselves that the answer is to 2 decimal places. First, write out the cosine ratio, putting a 1 under the cosine theta. So we have cosine theta over 1 equals adjacent over hypotenuse. Repeat this, putting in the values for theta and the hypotenuse. So we have cosine 41 degrees of 1 equals y over 21.2. Now cross multiplying, top left by bottom right equals top right by bottom left. So y is equal to 21.2 multiplied by cosine 41 degrees, which equals 21.2 times 0.7547, which gives us 15.9996. Therefore, the adjacent side y equals 16.00 centimeters to 2 decimal places. Now let's look at the third type of problem. You are given the hypotenuse and the adjacent side and required to work out the angle. So let's do our third example. A right-angled triangle contains an angle theta with its adjacent side measuring 19.9 centimeters and the hypotenuse measuring 27.2 centimeters. Calculate the angle theta. So writing this out in a line, hypotenuse equals 27.2 centimeters, the adjacent side is 19.9 centimeters, and theta, we need theta to 2 decimal places. First, we write out the cosine ratio. Cosine theta equals adjacent over hypotenuse. Repeat this, putting in the values for the hypotenuse and the adjacent side. So we get cosine theta equals 19.9 divided by 27.2, which equals 0.7316. Punch the cos minus 1 function on your calculator and enter 0.7316. Press the equals sign, and we have theta equals 42.9793 degrees. Therefore, theta equals 42.98 degrees to 2 decimal places. And that's all, folks. In the next tutorial, we will examine the tangent ratio and show you how to use it with the usual bag of worked examples. Anyway, thank you for watching. Oh, and don't forget to subscribe. You don't want to miss the latest vid. See you all soon.